Alright, so now we're going to do number 1. So here we have a curve that is given by 3t squared I plus 3tj minus 2t cubed k. So the first thing to realize here is that I, j, k, they're all the unit vectors. So you're going to consider them more like a direction or a marker of different coordinates. If they look confusing to you, it's always okay to transform it to a vector form, which is using the triangular brackets, like that. Alright, so part A, compute the speed at time t equals to 1. So to compute the speed, it is defined as the magnitude of velocity. And to find the velocity, it's going to be the first derivative of r, which is going to be a vector. So the derivative of each coordinate, which is 63 and negative 60 squared. And then the speed is going to be the magnitude of that. And we're plugging in t equals to 1. So that is going to be 6 squared plus 3 squared plus negative 6 squared, again 36, and that's 7281. So our speed is going to be 9. And then part B, compute the acceleration vector at time t equals to 5. So acceleration is going to be the derivative of velocity, or the second derivative of the original path. So we're going to take the derivative of this vector. So that's going to be 6, 0, and negative 12t. And we're looking at t equals to 5. So plug in 5. And that's going to be 6, 0, negative 60. And then part C, we want to find the arc length of the curve segment between the points 12, negative 6, 16, and 3, 3, negative 2. So to set up the integration for arc length is basically a single integral of the speed dt. And to find the actual length for the line segment, we need the boundaries for the t here, which can be found from these 2 points. So we have the path as this. Then the easiest way is to take the second coordinate, which is 3t, and match it with the numbers we're having here. So 3t equals to negative 6. Then we're going to get t equals to negative 2. And similarly, 3t equals to 3. Means t equals to 1. So our setup will be negative 2, 1, and the speed inside, which is this term. So let's work out the squares first. The first term is going to be 36t squared plus 9 plus 36t to the fourth dt. So to compute this integration, we need to first simplify the inside. And we can find it to be pretty convenient that the inside of the square root is actually a square of something. So a quick review for the square is that a plus b squared will equal to a squared plus 2ab plus b squared. So now, if we say our a squared to be 9, which is 3 squared, and then b squared to be this term, which is 6t squared squared, then our 2ab term will be 2 times 3 times 6t squared, which is 36t squared, matches the first term. So this actually works, and our a plus b will be 3 plus 6t squared squared, negative 2 to 1. And then the square roots will be cancelled out with the square. So we're actually working with just 3 plus 6t squared here, which we can find the antiderivative really easily. That's going to be 3t plus 2t cubed. Plugging in, negative 2 and 1. So we have 3 plus 2, that is a 5, and then minus negative 6, minus 2, 16. And we're going to have a result of 27 for the length. Okay.